Assalamualaikum and good day everyone. Today we will learn on Chapter 5, Modified Reserve System. As an introduction, the premiums received by a life insurance company from the policyholder is gross premiums. So gross premium consists of net premium plus an additional charge for expenses, contingencies and profit. And we call this additional charge as loading. Under the net level premium reserve system, the premium is a constant percentage of the gross premium. The major expenses incurred by a life insurance company in issuing a policy must be met in the first policy year. So the major expenses incurred in the first policy year, while the expenses incurred in the renewal years, the policy years following the first policy year, are comparatively smaller than the expenses in the first policy year. In most cases, the expenses to be paid in the first year will exceed the loading available under the net level premium basis. As a result, under the net level basis, the insurance company is unable to pay the entire first year expense out of the first year loading. This surplus will be repaid gradually during the subsequent years when the expenses are smaller and the loading available. So the expenses after the first year will be smaller, then it will cover the first year expenses. Alpha is the initial net premium in the first policy year and the renewal net premium. So the premium after the first year we denote as beta. So if we draw the timeline, so the first policy year we denote it as alpha and the subsequent years are beta, and at some point it becomes net level premium, where G minus 1 premiums of beta until G becomes beta, and M minus G premiums of P. So P will be until M years. So this is P, G minus 1 is beta. Present value of all net premiums at the inceptions equal present value of the benefit. So this is present value of modified net premium, including the initial net premium, the renewal net premium times the annuity at age X until G minus 1 for G minus 1 years, plus the premium times this is the deferred annuity due for G years for this net level premium. So the deferment is G years equal to present value of net level premium. So this is another equation where alpha plus beta times the annuity equal to the net level premium for G years. And finally we get this equation. This is the fundamental relationship between modified net premium and net level premium. So these two equations are very important. Now we go to modified reserve. First is retrospective method, where T less than G. So look at here, G is here. So when T less than G, modified reserve, we denote it as TV with the prime. And this is TEX. We found in life insurance last semester This is for pure endowment, where dx plus n over dx in terms of commutation function. And this is the accumulated value. Because this is retrospective, so we use accumulated value. And second one is prospective method. So this is the benefit minus the annuity times beta, and this is deferment annuity times the premium. The difference at the end of the ith policy year between the net level reserve and the modified reserve. Hence, the level reserve may be expressed as this equation. And we simplify and we get this one. So this is net level reserve. And V with the prime is modified reserve. This equation states that at the end of any given year, the reserve under the net level system exceeds the modified reserve by the PV of the difference between the net renewal premiums. So beta is the net level renewal premiums payable in the future under the modified system, and the corresponding net level premium. So P is net level premium. The larger the difference beta minus P, or the renewal premium minus the net level premium, the larger will be the difference between corresponding terminal reserve. So terminal reserves is the reserve at the end of the policy year. As T increases, the annuity value becomes smaller and the difference beta minus P decreases progressively until finally these two reserves are equal when T equal to G. The modified reserve greater than net level reserve because under the modified system, larger net premium will be saved to reserve in the future. Now we look at the diagram. This is gross premium that we charge the policyholder, and the net level premium is below the gross premium. So this is the alpha, the first year net premium, and this is beta, the renewal net premium. And the shaded region is loading. Loading, which consists of the expenses, the contingencies, and the profit. And starting from G, it becomes net level premium. So this is P. We use P in the timeline, and this is beta, and this is alpha. The diagram shows a G-year modified period with an M-year premium payment. The effect of modification upon loading can be illustrated using the diagram. So P prime is the gross premium and net level premium is P without the prime. So no prime here. So the loading is the shaded area. So P prime minus alpha, the policy year. P prime minus beta, each renewal year during the modified period. And P prime minus P, this is the net level premium from the end of the modified period to the end of the premium payments period. While under the net level system, the loading is P prime minus P for every year. Because for net level premium, we do not take into account the loading. And this equation is the PV of the loading under the two systems is precisely the same. Thus, modification of net premium means that a part of the loading available in the renewal years under the net level system is borrowed for additional expense in the first year, reducing the loading available in renewal years. So the loading for the first year is greater than the subsequent years. So this loading covered the first year loading. In the modified system, the excess of first year loading over renewal year loading is this equation. Now we try example 1a. For a 1020 payment life policy issued at age 30, compute the value of beta if alpha has a value of 10 ringgit with a modification period of 20 years. So beta, we have to find beta. So x equal to 30, alpha is equal to 10. The 20 payment M, the 20 payment is equal to 20, and G also equal to 20, the modification period of 20 years. So this is G. G also 20. So we use this formula, alpha plus beta times the annuity equal to the premium times the annuity due. So we simplify this equation in terms of beta and we got this equation. Now look at this one. Annuity immediate can be written in terms of annuity due. And MPX that we covered in last semester for the net level premium. So MPX is the insurance divided by the annuity, the temporary annuity. So now we can calculate the equation. So this is actually the insurance. The benefit AX is equal to MPX times the annuity for M years minus the alpha, and then we substitute the values of alpha, and this insurance and annuity we refer to the life table, and we got 21.9439. So beta must greater than alpha. Okay, so for B, and we can use this formula to find the excess values. And we simplify the equation and we get this one. And we substitute the values, the beta and alpha. And this is X plus T. So X is 30. T is the 10th policy year. T is 10. So G minus T, G 20 minus 10, and this is XG, and we refer to the table and we get 6 ringgit and 89 cents.